and welcome back to my YouTube channel. So today's video is about the important questions for the instrumental method of analysis, which is in your semester 7 of B Pharmacy final year. So the number one thing that you need to know is the concept of chromophore and the concept of oxochrome. So chromophore are of two types. One that are pi 2 pi star and n 2 pi star. These are basically electronic transition. You'll study them in detail. And the other is just pi 2 pi star. So these are the two types of chromophores. So basically chromophore is any moiety. It is an isolated nucleus that is responsible for imparting color to a particular compound. And oxochrome, it cannot impart color. It increases the color intensity, the color absorbing ability of the chromophore. And majorly it includes OH, NO2. These are NH2. These are few of the electron donating groups. NO2 is an electron withdrawing group, but OA, amines and hydroxyl, these are electron donating groups that act as a chromophore. The next is the Beer-Lambert's law. Beer-Lambert's law, basically there's a big derivation, and that derivation is very, very important with respect to your semester. A is equal to ABC or A is equal to epsilon BC. So these are two of the final equation, that is where A is the absorbance, A is the specific absorbance, B is the path length, C is the concentration, epsilon will be the molar absorptivity. So whenever we express molar absorptivity, the concentration will be in moles per liter, and in specific absorbance the concentration will be in grams per 100 ml. In electronic transition, the next topic, which is very, very essential, the things that we have are four types of transitions: sigma to sigma star, n to sigma star, pi to pi star, and n to pi star. So basically sigma to sigma star is in the vacuum UV region. That is why it is not much of vital importance. N to sigma star basically consists of non-bonding electrons and sigma electrons, of course. Here it consists of both the sigma electrons. Again, it is also around in the range of 150 to 200. So that is also vacuum UV again. N to sigma star. Then you have pi to pi star. That is very important. And also remember, N to sigma star is basically used as a solvent. These are used as solvent because the cutoff wavelength, the wavelength below which there is absorbance, above which there is no absorbance. Pi to pi star, these are basically showing K bands. They are allowed transitions, and also excited state is more polar, so it can show bathochromic shift, which is the red shift. And also remember that the wavelength will be more, the energy will be less. And the last you have is N2 pi star, which are R band. They are forbidden transitions. They are called as forbidden because the epsilon max is less than 10 raised to 4. If the epsilon max is more than 10 raised to 4, then they will be called as allowed transitions. So these are a few information about the transitions. Next is flurimetry. In flurimetry, the most important concept is the Jablonski's diagram. So the Jablonski's diagram and the expression, the Jablonski, I'll just write the spelling for you all. So suppose if this is the ground state, this is the first excited state, this is the second lower energy excited state, and this is a triplet excited state. TE, singlet excited state, lower singlet excited state. So from ground state, there is absorption of UV radiations and it reaches the excited state. So when it reaches the excited state, it then further emits radiations and it loses energy and it moves back to a lower energy levels. This is called as internal conversion. When it comes back to the lower ground state, it is called as external conversion. And when it vibrates like this, there are different excited energy levels. So when it vibrates like this in the similar state like this is termed as vibrational relaxation. These are all means of deactivation, vibrational relaxation. These are all deactivation techniques. The next that you have is inter-system crossing. This inter-system crossing is basically from singlet to triplet. So from singlet excited state to triplet excited state, there is inter-system crossing. Why is it? Because from singlet, there is another system which is a triplet. So always remember that there is a singlet ground state, singlet excited state, and triplet excited state. In triplet excited state, there is a change in the spin, change in the spin. While for singlet excited and singlet ground, there is no change in spin. There is presence of pair. Here there are same spin. They are unpaired. Also in the triplet excited state, if it goes, it will show phosphorescence. While here it will show fluorescence. When we switch off the cutoff or switch off or cut off the source of radiations, fluorescence will immediately stop, but phosphorescence will go on emitting radiations. Phosphorescence is a more sensitive and a more different phenomena than fluorescence, because phosphorescence is highly selective and it is more and it require and there is more loss of energy. So phosphorescence is different from fluorescence. And from fluorescence, there are a few factors that affect quenching. Now, what is this quenching? Quenching is basically reduction in the fluorescence intensity. Quenching is basically reduction in the fluorescence intensity. So, there are different factors like dissolved oxygen, temperature, viscosity, nature, rigidity. In nature, you have electron donating group and electron withdrawing group. So these are the few factors. If you increase the rigidity, there will be increase in the fluorescence intensity. Here if you see, I am drawing two diagrams. This is biphenyl methane. This is also biphenyl methane, but here this is fluorine. Why fluorine? Because there is a increase in the rigidity of the molecule. There is a more rigid structure which is formed. So nature, electron donating group increases the fluorescence intensity. Electron withdrawing group decreases the fluorescence intensity. More the temperature, lesser the fluorescence. More the viscosity, greater the fluorescence. More the dissolved oxygen, lesser the fluorescence. These are the essential factors that affect the fluorescence and quenching. Quenching can be either static or it can be dynamic. In dynamic, again, you have collisional and chemical. Basically, they either dissipate heat or they form a complex, due to which the fluorescence intensity will be reduced. So this is what is quenching. In UV spectroscopy, what is remaining is the deviations. There are three deviations that you need to remember. from Beer-Lambert's law. And when will it deviate? When their solution is too dilute or the solution is too concentrated. Real, spectral or chemical. These are the three deviations. In real, it can be either interaction with the neighboring molecules, speed of light, refractive index. In chemical, it can be either association, dissociation, pH, polymerization. In spectral or instrumental, you have mismatched coverts, stray radiations, polychromatic light. These are the few examples of the deviations that are causes or the ways in which there would be deviations. And one more thing that you need to study, and that is a must ask question, is a UV spectroscopy instrumentation. In instrumentation, basically you have an entry slit, a collimating lens, a wavelength selector, a focusing lens, and a exit slit. Then you have a further detector and recorder or an amplifier. In detector, you have photocell, photodiode, photomultiplier tube, photovoltaic cell, photosilicon diode, this is PSD, and photovoltaic cell or barrier layer cell. So these are the four types of detectors. And again, wavelength selectors, we have two types, monochromators and filters. Filters, we have absorption and interference. Monochromators, again, we have two types, gratings and prisms. Gratings again is classified into two, transmission gratings and reflection gratings or diffraction. Prisms is classified further as cornu and litro. So these are the entire classification. Now you have to study the difference between gratings and prisms. You have to study about the difference between monochromators and interference filters, you can say. You have to study about the difference between absorption filters and interference filters. There's a difference in the narrow bandwidth, in the throughput efficiency. So that you have to study. That is very, very important. The next we have is unit number 2, where we have the most important IR spectroscopy. In IR spectroscopy, you have to study out the sampling preparation. Sampling preparation of solids. That is very, very important, especially nujols and potassium bromide. These two are the techniques. Nujol is basically paraffin hydrocarbon mineral oil. Paraffin hydrocarbon mineral oil. KBR ka pellets. There is it is formed by pressing in between two discs. It is sandwiched to obtain a single disc. So again, one more thing important in IR is the detectors, whereby you have bolometer, Gole cell, thermistor or a thermocoupler, photoconductivity cell. So these are the few of the detectors in IR spectroscopy. And the sources of light are also very, very important, like Nernst globar, and incandescent lamp. Nernst globar, and incandescent lamp. These are the few important sources of light in IR. In IR, there are basically vibrations and rotations. In UV, there are electronic transitions. The IR is further divided into three regions: near IR, mid IR, far IR, fingerprint region, and functional group region. So here what is more important is the range in the wavelength and in the terms of wave number. Wavelength in the terms of wavelength and in the terms of wave number. You need to know, like near IR is 0.8 to 2.5, mid IR is 2.5 to 50, and far is 50 to 1500, and the wave number is 12,500 to 4,000, 4,000 to 400, 400 to 40. Similarly, this is very, very important in fingerprint as well as functional group region. Always remember that in fingerprint region, there will be bending vibrations. And in the functional group region, there will be stretching vibrations. That is very, very, very important. And the bending and stretching vibrations are types of vibrations. Here we'll see there are two types of vibrations: fundamental, non-fundamental. Non-fundamental, you have Fermi's resonance, combination, and overtone. Fundamental, you have two types, bending and stretching. Stretching, you have again two types, symmetrical stretching and asymmetrical stretching. In bending, you have two types, in plane, out plane. In out plane, you have again rocking and twisting, which are the two types, twisting and wagging. In plane, you have scissoring and rocking. Scissoring and rocking. So these are important with respect to IR, the concepts. The next you have is flame photometry. Here you have to study about the two types of burners, total consumption burner and pre-mixed burner. One is called as a streamline burner and one is called as a non-streamline burner. So flame photometry ka basic principle is, firstly, you introduce a liquid sample. You introduce a liquid sample which gets volatilized or desolvated to form a solid residue. This further gets volatilized, atomized to form small mist or gaseous particles. This further undergoes excitation due to exposure to the flame and may ionize and dissociate. This is then detected by the detector or the photocell. So flame photometry is basically atomic absorption or atomic emission spectroscopy, depending upon the nature. It can be atomic emission also, it can be atomic absorption as well, and that is very, very important. So the next is atomic absorption spectroscopy. Here you have to study mostly about the electrode-less discharge lamp and the hollow cathode lamp. ECL and HCL, electrode-less discharge lamp and hollow cathode lamp. And you have to study about the interferences. There are different interferences like spectral, chemical, ionic. These are the different types of these are the different types of interferences. Now, in interferences, you have mostly about cationic and oxide. So the only that is to be studied. Next is the difference between nephelometry and turbidometry. Nephlo is at 90, turbido is at 180. Nephlo is for dilute, turbido is for concentrated. Nephlo is basically scattered particles ka measurement. Turbido is basically transmitted particles ka measurement. Nephelometer may you use nephelometer, Eales nephelometer and Dubosco's turbidometer. Here you use a turbidometer. The principle of nephelometry is similar to that of fluorimetry, while the principle of turbidometry is similar to flame photometry or calorimetry. And the most important is the factors that are affecting, like the concentration, temperature, agitation, wavelength, particle symmetry, etc. So that is very, very important when we speak with respect to unit number 2. In the next unit, we have types of chromatography, and wherein we have to study about the Van Deemter's equation and the chromatographic classification like isocritic, gradient, preparative, analytical, based on the party adsorption or partition. And there are qualitative or quantitative chromatography, which is based on solid, liquid, liquid gas, or solid gas. So these are few of the types of chromatography techniques depending upon the nature of the solute and the technique that you want to prefer. Like if you want to isolate and purify, you will go for preparative. If you want to just separate and identify, you will go for analytical. Isocritic is basically when you have a limited mixture, a limited polarity and sample. But when you go for gradient elution, you can separate a large variety of the particles. So electrophoresis you have to study about the slab and the moving boundary. Moving boundary, basically you have to study about the capillary electrophoresis. The factors affecting electrophoresis, and in slab you have to study about the gel and paper. Gel में mostly you have to study about the SDS page, which is the sodium dodecyl sulfate polyacrylamide gel electrophoresis, and agarose gel electrophoresis. These are the types of gel. These are different types of gel that can be used for this electrophoresis. Column and TLC, you have to study the difference between HPLC, TLC, or column and planar chromatography. That is very essential when we speak about with respect to semesters. The next is unit number 4. You have to study about the importance of derivatization in GC. Very important. There is pre-column and there is post-column derivatization. Either alkylation, alylation, silylation, acetylation. Why is it done? To convert a polar into a non-polar. And why is that done? Because we have to make it more thermostable, volatile, increase the detector response, increase the sensitivity. These are the different objectives behind derivatization. In HPLC, basically you have to study about the pump and the injecting system. So whenever you go for unit number 4, always see to it that you follow this sequence that I'm going to tell you, because that is very important. Suppose this is HPLC, this is GC. Okay. So firstly, you have to study about the injector. Injecting system in HPLC is rheodyne or 6-port valve injector. In GC, it is split and splitless. Here next is column. So inject a column में HPLC में you have pre-column, guard column, analytical column, main column. Here you have packed and capillary column. In capillary again you have wall coated and support coated. Next you have is column packing. Here you have carbovaxis, polyethylene glycol, etc. Here you have bonded, pellicular, microporous. Next is detectors. Here you have TCD, FID and ECD. Here you have bulk and solute property. In bulk property, you have refractive index, you have nephelometry or scattered turbidometry. Solute property, you have UV, PDA, fluorescence. PDA is basically similar to UV, but the only difference is the polychromatic light. In UV, we use a monochromatic light. Now, what is this monochromatic and polychromatic? Monochromatic is basically a single wavelength. From the name itself, break the word. Mono means single, chromatic means color. A single color wavelength. A photodiode array is basically a wide range of wavelengths. So that is more of a solute property detector. And need of derivatization and operated. It is basically HPLC is operated in the reverse phase, which is in which the stationary phase is non-polar and the mobile phase is polar. Derivatization is mostly in GC. Pumping system. There is no pumping system required in GC. Carrier gas. There is carrier gas requirement in GC, not in HPLC. Pumps. Here we have constant pressure pump, which is a pneumatic pump, syringe pump, and the constant displacement or reciprocating pump. So these reciprocating pumps can be either single or dual or double, that is single dual. So double reciprocating pumps are widely used because it provides a pulseless flow. There is no pulsed flow. So that is what is importance of the pumping system. And pulse dampener is basically most important in HPLC and not in GC. So that is again very important. And flow regulators. Flow regulators are basically needed in GC because the flow, there is a different pressurized flow. So in GC, we need flow regulators like soap bubble, rota, flow meter, so on and so forth. And in HPLC, there's no need as such, but we can incorporate a flow regulator. So these are the few differentiation points. In this way, if you study, you can compare and you can actually write a lot of data from both the from both of them. So that is very, very important. And the two theories of chromatography. There are two theories of chromatography that is very, very essential and important. One is the rate theory and one is the plate theory. So the plate theory is basically, the rate theory is also called as kinetic theory. Let me tell you that as well. So basically they are imagining that there are small, narrow, discrete, continuous and hypothetical plates packed in a column. So the height, length and the number of plates will be useful in the column optimization and resolution. In the column optimization and resolution. So this is what is important. H is equal to L upon N. Next we have is the unit number 5, wherein you have to study about few important chromatography specialized techniques. But before that, I would like to mention few important terms that you will come through during this. The Frank codons principle. You will study about this in the UV and the fluorescence. Stock-Volmer's quenching. This is very, very important phenomena of quenching. Retrodelelder, Tropolium, McLefarties, and these three are in NMR, that is not in your syllabus, but I've still included this because they are important with GPAT point of view. The Pascal's triangle, that is also not in your syllabus, but yes, it is very important with respect to GPAT. The next you have is Stahel's triangle, which is in UV chromatography technique. When we have to select the mobile phase, so chromatographic technique, you will find Stahel's triangle. Fermi and Stokes resonance, these are very, very important phenomena. Stokes shift and anti-Stokes shift in fluorescence and IR spectroscopy. So just once have a brief view about the Stokes and anti-Stokes shift. Tyndall and Rayleigh scattering, these are in nephroturbidometry. These are the few phenomena. Also, besides this, you have many other Doppler's effect, Zeeman-Stark effect and all, but that is not so important. Jablonski's diagram from the fluorescence. So these are few of the important terminologies that I wanted you to get acquainted with for GPAT and for your semesters. So these special chromatographic techniques basically include gel, ion exchange and affinity. So whenever you study, see to it that you study in, again, a comparative format, because these are very, very special chromatographic techniques. They are used for macromolecules, they are used for charged species, they are used for specificity like ligand, substrate, antigen, antibody. So this is important. Gel chromatography and affinity, you have to study the principle of all the three. Like in gel chromatography, the larger molecules will quickly elute out, while the smaller molecules will interact with the pores and will take more time. So here you have to study about the two terms, total permeation volume and exclusion volume. In affinity chromatography, what is more important is the affinity. That is, you have a matrix, a spacer arm, a ligand and the solute. So whichever solute will be having more affinity for this ligand, it will bind like this. And the other will not bind and elute out. So this is the basic principle in of affinity chromatography. In ion exchange, you have cationic ion exchange capacity, wherein you have cross-linking. If there's more cross-linking, there is more rigidity of gel. If there is more rigidity, there is less separation due to less swelling. This is very, very important phenomena that I want you all to know. More cross-linking, more rigidity, lesser separation, lesser swelling. And in ion exchange, you have two types of exchangers, cationic and anionic. If it's a cationic exchanger, the solute will be cation. If it's an anionic exchanger, the solute will be anion. So that is very, very important. And cationic again is classified into two, strong cationic exchanger and weak cationic exchanger. It is anionic is classified as strong anionic exchanger and weak anionic exchanger. So this is very, very important with respect to the chromatographic techniques. And that's all for today's video. Thank you so much for watching. You can connect with me through any of these pages and media. And I hope to see you all in the next video. Kindly drop your precious comments in the comment section. Thank you so much.